Hi everybody, my name is John Rowley and I'm a professor of chemistry at Carroll College. This is a follow-up video to a live activity we did learning about chemistry and chemical reactions. This is a video for those of you that couldn't attend the live event. You can go through the whole activity on your own. So today what we're going to learn about is chemistry and chemical reactions. Specifically what we want to investigate is how the speed of a chemical reaction depends on the temperature. That is, if I heat up a chemical reaction, does it go faster or slower? Or if I cool down a chemical reaction, does it go faster or slower? So that's what we're going to investigate today. Before we start, let's just talk about what are chemical reactions. You actually have encountered a lot already. An example of a chemical reaction is burning wood. That's a chemical reaction where the material the wood is made out of is converted into gas, CO2, and water vapor. Another example would be if you have a cut and you put hydrogen peroxide on your finger, it produces those little bubbles. That's another type of chemical reaction. Another example would be if you leave milk out and it goes sour and smells horrible, that's another type of chemical reaction. So you've encountered those type of things before. What we want to think about today is specifically what happens to the atoms or molecules in a chemical reaction as the reaction occurs. And when I say atoms and molecules, I'm talking about the little tiny particles or pieces that everything around us is made up of. Okay, what actually happens to them? So in today's experiment, what we're actually going to do is we're going to look at blue food dye and we're going to react it with bleach and see what happens. There are two parts to this activity. The first part is we're going to act out the chemical reaction. So you will get to pretend to be the bleach molecules or the sodium hypochlorite molecules, and you will actually act out the chemical reaction destroying the blue food dye. After that, I'll do a kind of demonstration experiment where I do the real reaction with the food dye and the bleach, and we'll see if our hypothesis or our guess about how chemical reactions are dependent on temperature, we'll see if that guess is correct when we do the real experiment. So for the activity that you're going to participate in, what you'll need is a piece of paper that you've colored all blue on one side and then left the other side white. Then take that piece of paper and cut it up into a bunch of little squares, kind of 2-inch by 2-inch type squares. So that's what you'll need for the actual first activity, and you'll also need a stopwatch. For the second activity, I'm going to do the demonstration, but if you wanted to do it on your own, you could get some blue food dye. I've made a big jug of it, just in case you want to do it multiple times, and you'll need some bleach and a measuring cup, like a half or a quarter cup measuring vessel. Okay, so that's what you need. If you don't have the piece of paper cut out that's blue right now, go ahead and pause the video, take a few seconds, get that ready, and then come back. Okay, let's talk about chemical reactions specifically. There are actually 3 requirements for a chemical reaction to occur. Because we're using blue food dye today, I've chosen some blue Legos to talk about this chemical reaction. So we'll pretend the blue Legos are the blue food dye, the little molecules that make up that blue food dye, and we'll pretend my hand is the sodium hypochlorite or the bleach. So in order for the bleach to react with the food dye, 3 things need to happen. First of all, they need to touch each other. They need to collide. Okay, that's the first requirement. They also have to collide with the correct orientation to get the reaction to happen. And let's pretend me snapping it apart, that's the chemical reaction happening. So in order for a reaction to occur, the molecules or particles have to collide with each other. They have to collide with the correct orientation. Notice that if I grabbed over here, I can't pop it, or if I grab over here, if I grab over here, I can't pop it. They have to collide with the correct orientation. And then the third requirement is they have to have enough energy to do the chemical reaction. It takes a little bit of energy, not a lot, but a little bit of energy to pop those apart. So again, the 3 requirements are they have to collide with the correct orientation and they have to have sufficient energy to get the reaction to occur. Now, what happens to those 3 requirements as we change the temperature? As we increase the temperature, the molecules actually collide more often. They move faster, so they bump into each other more often. changing the temperature doesn't really change how often they bump into each other correctly, but it does change the third one, how much energy they have. So as we increase the temperature, the molecules bump into each other more often, and they have enough energy when they do bump into each other. Okay, so with that in mind, what I'd like you to do is go ahead on a piece of paper or your notebook, go ahead and jot down your guess or your hypothesis as to what's going to happen. And I'd like you to write something like, the chemical reaction will go, and then you fill in this word, either faster or slower, when heated. So go ahead and pause the video and choose which one. So the chemical reaction will go, and then you choose one of these words, faster or slower, when heated. So when heated, will it go faster or slower? Go ahead and pause the video and write down your hypothesis. Okay, hopefully you've written down your hypothesis. Now for the part where we're going to act out the chemical reactions and we're going to pretend to be the bleach, the sodium hypochlorite. Again, you are pretending to be the hand, the bleach molecule that breaks apart the blue food dye. This is where we need your little blue cards that are blue on one side and white on the other. What I want you to do is spread out these cards all over your floor with the blue side up. Then what you're going to do is you're going to pretend to be the bleach molecules, and you're going to go around and flip the card to do the chemical reaction. That's just like the bleach molecule coming in to break apart the blue food dye. Okay, so you're going to pretend to be the bleach, and you're going to do the chemical reaction by flipping it. All right? We're going to do this experiment 3 different times. You're going to do it where you're going to pretend to be a cold molecule, so you're going to move very slowly. To be a cold molecule, you're going to walk backwards, heel to toe. Backwards, heel to toe, moving very slowly. Then I want you to flip, and we're going to time you and see how long it takes. Then I want you to flip all the cards back to the blue side, and now you get to pretend to be a warm molecule. So you can walk forwards, heel to toe, flipping the cards. And we'll time you and see how long that takes. And then finally you get to be a warm molecule. So you get to walk big steps kind of as fast as you want, flipping the cards over, and we'll time you. So before we start those 3 experiments, I've written down my experiments, number 1, 2, and 3, cold, warm, and hot, and then I left a space over here for the time it's going to take. So we're going to act out this chemical reaction and see which one is faster or slower, the cold or the hot, and see which one works. Okay, go ahead and start. So you're pretending to be the cold bleach molecules, and the cold molecules move very slowly. So she's walking backwards, heel to toe. And we're timing how long it takes her to do the chemical reaction, where she flips the blue card over to the white side, and that's pretending to be the bleach molecule breaking up the blue food dye and making the solution clear.
So she's moving backwards, heel to toe, because the blue food dye, or the bleach molecules move very slowly when it's cold.
One more and done.
So that took about 1.5 minutes to flip them all over. And that was where she was the cold molecules moving very slowly. Okay, now she's going to pretend to be a warm molecule. So she's going to move forward heel to toe. Okay, so this is not slow, not fast, but kind of a medium speed. Are you ready?
Yes.
Okay, here we go. You can start now. So now she's walking forwards, but still heel to toe.
One more and done.
Great. And that took about a minute. Now she's going to pretend to be the hot molecules. So she's going to walk forward kind of quickly and turn over the cards to do the chemical reaction. Are you ready?
Yep. And one more and done. 23 seconds.
23 seconds. Okay, so after acting out the chemical reaction where we had the blue food dye molecules on the floor and you flipped them to do the chemical reaction, this is the data I recorded where the cold experiment, that took almost a minute and a half. The warm experiment, number 2, that took 54 seconds or almost a minute. And then the hot experiment where the molecules were moving very quickly, that was very fast and it only took 23 seconds. So it looks like, based on that first acting out the chemical reaction, it looks like the warmer you make the chemical reaction, the faster it'll go. Now that we've done that, let's try the actual chemical reaction where we mix the bleach with the blue food dye and see what happens. Okay, for this part of the video, we're actually going to do the chemical reaction. So here we have our solutions of blue food dye in water. I have a hot solution. I just microwaved this. Here's the warm. This is just essentially room temperature. And then here's the cool. I had this one in the freezer for a little bit, not very long.
I'm going to add the bleach solution to the cool first. And then the warm. And then the hot. And then I'm going to give all of them a stir here.
Thank you for joining me for the chemistry activity today, where we investigated how the speed of a chemical reaction depends on the temperature. What we learned is that as you increase the temperature of a chemical reaction, that reaction goes faster. You encounter examples of this all the time in your everyday life. When you buy groceries and bring them home, you put them in a refrigerator to keep them cool so that chemical reactions don't happen to the food and they turn rotten. On the other hand, if you do want a chemical reaction to occur, like when you're cooking food, you increase the temperature so that those chemical transformations can occur more quickly. We also learned that there are 3 requirements for a chemical reaction to occur. The molecules have to bump into each other. So if this is the blue food dye and this is the bleach, they have to touch each other. They also have to bump into each other with the correct orientation, and they have to have enough energy to make the chemical reaction occur. As you increase the temperature, the number of molecules that bump into each other every second increases because they're moving faster. In addition to that, as you increase the temperature, the average energy they have to break the bonds to initiate the chemical reaction, that also increases. So that's the 2 components that contribute to making a chemical reaction go faster as the temperature increases. Thank you again for joining me. Again, my name is Professor Rowley. I'm from Carroll College. If you want to reach out and contact me, my contact information is available on the Carroll College Chemistry Department webpage. Thank you again for joining me.